Alright, so we're asked to expand this here up into the powers of x squared, okay? So first of all, we need to rewrite this, yeah? So we can see on the bottom we have a square root, okay? So remember with a square root, it can be written as a power, yeah? Okay, so that can be put in a bracket, written as a power half, okay? Because that's what a square root is. And then of course we need to take this up, okay? So we get, well, I'll have to put that in a bracket then, yeah? The first term there. And then if I take that up, it'll be a negative power then, okay? So we'll have 1 minus 2x to negative half. So we need to expand this. Now, of course, we don't need to expand this because it is what it is, right? The power is 1, so it's already expanded, okay? So there's nothing to expand there. Is this what needs expanding? Yes, we'll use the binomial theorem from the formula booklet. So let's just do that first, and then we can go back to this then later. So 1 minus 2x to the power minus a half. Okay, so we'll substitute the values in there. So we start off with 1, of course. Okay, the power n then is this here. Okay, so we're going to add on the power n, which is minus a half. Okay, and then your x. Remember then is that second term in the bracket, so it corresponds to this here. Now this time it's negative 2x, right? So don't forget the minus in front of it, okay, because that term is negative there, okay? And then, well, n, which is minus a half, okay? And then n minus 1, well, if I take away 1 from this, I'll end up with minus 3 over 2, okay? Because we subtract 1 from this, yeah? And that's what results from it, minus 1.5. All over them, well, this is what we call 2 factorial, which would just be 1 times 2, as is written in the formula booklet, so that's just 2. And then we've got to square this then, so square this, remember to put it in a bracket, okay? Put it in a bracket so that we're squaring the whole thing, okay? Not just the x, you've got to square this as well. And we just keep going then, on and on, alright? So we only need up to x squared though. So let's simplify this. That's 1 minus half times minus 2. Well, 2 minuses make a plus, and half times 2 is 1. So it's just going to be plus x. Here then, minus a half times minus 3 over 2. Okay, well, 2 minuses make a plus. So that will be 3 over 4, and then divide that by 2, 3 over 8. Okay, so plus 3 over 8. You can check on your calculator. And then when you square this, or square it, well, you get positive 4 there, yeah? Okay, because minus 2 all squared, minus 2 times minus 2. Don't forget to square the x as well. Simplified then, this will be 1 plus x. So times the 4 by that then, okay, so we get then plus 3 over 2x squared. Okay, and there's our expansion for this bracket. All we need to do then is go back to this, okay, and then we can have our solution up to x squared. So we've got uh, 1 plus 3x, and then we put this expansion in place of this then, 1 plus x plus 3 over 2x squared. Okay, so let's start off expanding this then. While so we start off with the 1 here, so times everything in here by that 1. So 1 times 1 is 1, 1 times x is x, and 1 times 3 over 2 x squared is that. So it's just this bracket, isn't it? Because you're timesing it by 1. And then you've got to times everything then by the 3x. So 3x times 1 is 3x. 3x times x is 3x squared. Now I don't need to times the 3x by the last term, because you'll notice x then times x squared will be x cubed, and I don't need that. I only need up to x squared. So to finish off then, I'll have 1 x plus 3x is 4x, and then 3 over 2x squared plus 3x squared will be 9 over 2x squared. Okay, so there is my expansion up to x squared, and then it says then to finish off, we'll state the range of which it's valid for. So remember the formula booklet states that x has got to be less than 1, the size of x, but in this case, of course, our expansion bracket is this one. Okay, so we have to replace that with minus 2x is less than 1. Now with a modulus, the modulus just looks at the size of it, right? So that minus just disappears. Okay, and we can take the 2 outside of the modulus as well. And then of course we can take the 2 over and divide. So we get a half. So that means then x, the size of x, has got to be less than half. So it could be positive less than half or negative less than a half. Okay, so greater than negative half rather. Okay, so it's between minus a half and a half. Now we don't need to look at this bracket here, okay, because this is a finite expansion. It doesn't go on forever like this. So that can be valid for any value of x. But this term here, which we expanded, has to have x between these values. So the overall thing must be satisfied by these x values here for it to work.